The next stage in our duck hunt game is to help the ducks to move on screen, because it's kind of like shooting ducks in a pond right now while they're just sitting there flapping their wings but not going anywhere. So it's time to give them a little bit of life and movement. So the easiest way to do that is to add another function to our loop, because we could put all the logic in loop, but then loop becomes unmanageable. It makes much more sense to encapsulate this logic into an individual function. So I will call it move ducts. And this function, move ducts, is going to then cycle through all the ducks that are currently in the duck array. So we can just reuse this logic that we have under check for when that check to see, or that cycles through all the ducks and then removes them from screen. So we can use that logic. So I'll copy that, paste it in, and with that now we're going to take those ducks, and what we'll first say under move ducts is duck array dot y, and make the ducks move upward. And to do that, we'll have them go up. We'll just throw in an arbitrary speed value of 10, so that will make the ducks move up screen 10. But what I do want to do is, if the duck has now moved off screen, I do want to remove it from the list so it's no longer in memory, taking up space, it's no longer troubling my project. So I can say if duck array dot y is less than 0, and it's at that point then we can remove it. Rid of this, move this over so it's all nice and clean. Now, just so that we know what's happening, I like to trace out a message just so I know that the duck is being removed, since it's happening effectively off screen so we can't see it. So it is nice to have that little message occurring with us. So at this point, this is going to cycle through the array of ducks, and it will tell the duck to start flying upward. I'm also going to modify the duck's starting position, because it makes more sense for the duck to start at a lower portion on screen so we have a little greater opportunity to hunt for them. So what I want to do is to take my basic duck starting position, which is going to be under, I think, duck spawn, so not at the top but down at the bottom, and instead of having it be at this full amount of the stage, what we need to do is get it further down. So I need to have a lower amount. So if we say half of the stage height, so that's going to be putting it halfway down the stage. And if we wanted to only occur in the bottom half of the stage, we could say half of the stage, and then we're going to add back in half of it. We can just copy that, change the 50. And now this is going to put our duck hopefully in the bottom half of the screen. So if I test my movie, click, duck should show up at the bottom, and as we can see, they're flying up fairly quick, which is telling me that I probably will need to modify their speed to make it a little bit more easy to click on them. So what's happening is the ducks are moving too quick. So when they show up on screen, the height of the duck versus the amount they're moving each frame is too fast. But if we slow it down to a little more manageable amount, I should be able to score a hit. It also seems that the click event is proving to be problematic. So what we may wish to do is to modify it from a click to a mouse down event, which is going to be a little bit more reliable as a clicking option, because it doesn't have to register both the down and the up motion while the mouse is over the object, which is part of the problem using the mouse event.click versus mouse event.mouse down. So knowing that, we might be able to keep the high-speed ducts, and we can try again, but it is, and now that did prove to be more reliable. So we can use the 10, but it is certainly hard to get everything to work correctly with that. Next, I'm going to add a timer to the project. So to pull this off, I need a text field at this point, and I will type in time. I'll put some numbers in. At that point, it can be whatever we want. And this is not going to be static text, but it will be dynamic because it's a changeable field. So because it's dynamic, now I can refer to this as time left. It's an instance, so that gets a lowercase naming on it. We can make it bigger, and I want it left justified so that we don't end up seeing it keep moving on depending on how much time I am counting down. I'll wrap it in a movie clip. I'll call it timer field. And now I can delete that from my stage. Now going back into my code at this point, just like we have this in score box, bar timer field, movie clip, do it after score box. The timer field dot x will set equal to 20, so it just occurs at the same left position, but then we'll lower it so that's y equal to 80. And try that out as a starting value. Of course, we can change it to whatever value works. Now I really will want to put that under here, go add child, because it's part of the game, it's not part of the loading screen. So it's our timer field. So I can save, I can run this, and realize I got an error message because I forgot to provide a linkage name for it. So I can type it directly there, and it's still slightly unhappy. And it is important to also, before you reference something with adding it, we should probably say timer field equals new timer field. So I actually have to instantiate what that object is. And now it runs without a hitch. Click, and we can see there it is. It's not changing yet because we haven't added any of the timer options to it. So now the next stage is to actually add the timer to the project itself. Adding the timer is going to require creating a timer object. We can just call it timer, so it's type timer. That now adds in the timer object, we need to add in the timer event, which is going to be a timer event, so we will get that in a little bit when we add in the listening function for it. So this timer object, you can just put it here by the timer field, equals new timer. And now this is asking for a delay. The delay is how frequently the timer is going to count. And that number is measured in milliseconds. So if I enter in 1000, that means this timer will fire once per second. And then the repeat count is how many times I want it to fire. So if I want my project to run for 10 seconds, then I could say it has a count of 10. So at this point, my timer is instantiated, and all that's left for me to do is to tell the timer to start, and then I can give the timer event listeners about, hey, why don't you, listen for being done, listen for, it's very similar to using other event objects in the project. Now I find it useful for code completion purposes, to actually convince it to listen for the timer. So I'm going to say function timer count. This is going to allow us, every time the timer counts off a second, to fire out a message. And it's a timer event. And once I do that, it added in the import statement, so then at that point, while I am typing in my event listener, it's going to be a little bit more helpful. So I can now simply say timer dot add event listener timer event dot, and now it code completes what I want. And the basic timer event is for my counting. So I'll tell it to count. And I can also add a listener for timer complete, which will fire when the time is up. So there is now time is up and timer count. Both of these are tied to our timer object. One is going to fire every second that the timer broadcasts a message, timer event, and the other is going to be when the timer is done, it's going to broadcast out the timer complete. So I need to add in that second function, time is up. Now that I have those in, I can run it. We'll see there's no error messages. The ducts are moving, but the timer is not going yet. So now we need to instantiate and get the timer rolling. First way to pull this off would just be to do a simple trace to make sure we know it's running. And then I'm going to have it broadcast out. If we run this and start, we should see nothing occur yet, because we have one final activity we need to do, which is timer.start. And now that I've done that, hit go. We'll see time count is counting down, 3, 4, 5, and then so it counted for 10. To see it count a little bit easier at this point, I am going to just turn off the enemy spawn, so now when it runs, we'll just see the timer count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. On the 10th, our time is up. So we can see that it's working. 10 is enough time to try to create a high enough score, and we could set the score a little bit higher, so maybe I have to hit 2. For the purposes of our example, just to speed up development, we'll slow it down or shorten it so you only have 5 seconds in which to try to score. So now that we know that the count is working, instead of just tracing it out here, what would work better is to change the text inside the text field to reflect the correct number that's going on. In order to show text in text fields, what we really need to do is populate them, and we can do that by saying timer field time left. That is the instance of the text field, and we'll say its text property is now equal to time. And now we need to put a number on here, and the number that we're going to use is we're going to assign a variable, and this variable we will use, going to just call it current count. Now what we need to do is we want to update what's in that text field when the game loads. We need to define current count, and it's going to just be a number or integer, so I'll say int, and then when my game loads I'm going to initialize that value, so I'll say current count equals, and in this case I'm going to say 5. Now this number needs to correspond to in my timer object that, so realistically I could define current count, but I will need it under load game, so then if I have, when I replay the game, I will need to be able to reset it, so I should define it here. But I could also then have current count match here, so if I change that value, it's updating throughout. So I can set it here, but I could even set it here, and then with my timer I can say count. So at that point I'm updating that value. So I mean, that would be one thing I could do if I knew my project was going to get big enough and I would forget things along the way or change things, but I'm just going to leave it simple. So we will define the timer goes 5 times. Current count is here. We're putting the text field time is equal to the current count, and every click of the timer, then what we can do is just say current count minus minus. That is the same as current count is equal to current count minus 1. But I think the minus minus is just a little bit cleaner when looking at the code. Not minus 0 minus, just minus minus. Now, to verify that things are indeed working when it's done, so I'm going to get rid of this trace. I don't want needless traces. I'm going to take this, and we're just going to freeze the game using a removing loop. And with that we can click here 5, 4, 3, 2, 1, 0, and now the game stops and it's dead. Now this just proves that we can end the game. What I really want to have happen is the same kind of logic here under we have a winner, but perhaps when time runs out that means I haven't won, so then that would be a loser option. So I'm going to make a lose screen. We have a win screen, we'll have a loser screen, but then we can use everything else about the same, so we'll probably relocate that into its own function and just call that I've taken the winner screen, I've duplicated it, called it loser screen, changed the color and the text on it, so there's now a winner screen and a loser screen. And with that, I just need to create my loser screen. And it's going to be the same as the winner screen, so I'm going to just copy that and change winner to loser. So now there's the loser screen, and we'll be able to add that to the project. So it's going to be similar to check for win under this, where we'll remove loop, we'll add the loser screen, and then we can have all of this of adding the orange button, showing the mouse again, making it clickable, getting rid of whatever ducts are still on screen. All of that can be tied into a cleanup function, because I don't want to have that in two places. So I'm going to make my function cleanup. And so all of this under here, we'll just cut it out, put it here, and move it over. And now after we add the win screen, then we just say clean up. And with that, I'm going to copy that code there. When time is up, we'll now remove loop, add the what is now going to be the loser screen, and then call cleanup. So essentially the same, but one calls the winner and one calls the loser screen. Now, one other part of it that if I click on the button under this one, it's going to need to figure out if winner screen is on stage or if loser screen is on stage, and then remove accordingly. And the way that we can do that is we can say if winner screen dot stage is true. So we're asking, is winner screen on stage? And if the answer is yes, then we want to remove it. And then we'll do the same thing for loser screen. And this will allow us to remove the correct item by asking, is it on stage? So if I get two ducts, one, oh, I lost. But the shorthand way of writing this, with the by just saying if this is true, if winner screen stage or if loser screen is stage, then it does that. What we should also do as part of this resetting of the game, we reset the score, but we have not reset current count. So we haven't set current count equal to 5, and we have to tell timer to reset at this point. So if you realize what's happening here is there's a lot of information of mouse, blah, blah, blah. All of these things really are more under load game, which sets this, adds these objects, make sure everything is good to go, and starts the timer. So what we can do as part of this is, even though the timer even hasn't run yet, we could even reset the timer as part of it. So realistically, we can just recall load game versus listing all of these items here about rehiding the mouse, resetting the score. We can just call load game. So to prove that, we can comment that out and then just call the function load game. Verify some naming on here. Load game. So when it runs, oh, I lost. Okay, now my score. But if we notice, the timer hasn't reset, so I'm going to keep losing. So we do need to put a reset in here. So even before we tell the timer to start, we could say timer.reset. And that guarantees the timer is reset. 5, 4, 3, 2. Wow, that's a lot of ducks quickly. Lost. Timer's back. Starts over. I got 2. I won. But if we notice what's happening is, even if I win, I've lost, because even though I won the game, so even though I have won, what has not happened is the timer has not stopped. So the timer kept running in the background. So then it put on the winner screen, it waited, and then the timer fired off, and now it said I lost. So if I win, the first thing that should happen, so it should say timer.stop. And that will prevent it. No, I'm going to lose this game. Let's try again. I won. 2, 3, 4, 5. And I can sit here all day, and now the timer isn't going to cause me to lose. Scores reset. And this time I lost. Score reset. I lost. Apparently my game is almost too hard. I might need to modify the parameters, but we've proven the concept that it's working. At this point, now that we have a win screen, a lose screen, an opening screen, basic game logic for controlling the game, which is really everything that happens during loop, which is moving the crosshairs, updating what's in the score, and then spawning out enemies, making sure the crosshairs stay on top, and then we check to see if we've won, and we move the ducks. Now, remember that the ducks are moving up. We could very easily modify this game from a shooting at the ducks game to a catching game by making the ducks move down, which would be changing the minus to a plus. So instead of decreasing their y value, increase their y value, and then instead of looking for when they've gone above the stage, we would look for when their y is greater than the height of the stage, so when they're going down the screen. Otherwise, it would still be the same, and then change it from a duck. You could have things falling out of the sky. You're playing catch. Common games have been made this way, where you have like a baseball mitt, and then you have different objects falling out, balls or other things you're trying to catch. Some could be helpful, some could be harmful. So if you catch some objects, instead of catching it with and getting a positive score, they can subtract from your score. So there's really a lot of things you can do to extend this basic model of an interactive. But at this point, this is going to end what happens with Duckhunt and building this basic interactive project. Subsequent projects, it's really about modifying what you're calling during loop, but the main logistics of using a timer object, setting up your game, loading your game, or cleaning up, all of these things are going to be fairly similar as you go from project to project. So the nice part is it starts to become a little bit modular and is not something where you have to really reinvent the wheel from scratch in its entirety every time. Good luck and have fun.